Welcome to Statics Lectures by Civil Thinking, and today we are going to see another concept in equilibrium of rigid bodies. Now, this is a series of lectures on equilibrium of rigid bodies, and if you want to understand better, please watch the video lectures in sequence one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now, coming to the today's class. Today's class is about supports and connections, their concept, what are their types, how to find their reactions, what are the number of reactions in a support, and what are the number of reactions in a connection. Okay, now let's begin with support. Okay, now what is a support? Now support is something with the help of which a body rests on another body. Okay, now for example, you have two bodies here. This is body 1. Okay, and there is another body 2. Okay, now let us say there is something between them. Let us say there is something like this here, and there is something like this here. Okay, now body 1 rests on body 2. Okay, with the help of these two things, these are called as supports. Okay, supports, these are supports. Okay, supports are generally connected to the body. Okay, and the body too, it can be anything. It can be also the floor surface. Okay, like this. It can also be the floor surface. The body too can be floor surface like this. Okay, floor surface. Okay, body too. So support is something with the help of which a body rests on another body. Okay, now support transmits force from one body to another body. Now for example, body 1 have a weight W, right? Now this W will be supported by what? These supports, right? For example, this support will carry W by 2, and this support will carry W, half of W, right? W by 2. Okay, now this W by 2 and W by 2, they will go to the body 2. Okay, this floor right here, right? So in short, the force, weight is a force. Okay, weight or force is transmitted from body 1 to body 2, right? It is transmitted, but with the help of these supports. Okay, support transmits force from one body to another body. Okay, now different types of supports restrain motion in one direction and allow motion in another direction. Now these supports are of various types. Okay, these supports are of various types, which we are going to see in this class. Let me take an example. Let us say roller support. Okay, let me talk about roller support and pin support. Okay, now what is a roller support? Now roller support is something like this. Okay, these are known as roller supports. Okay, and you can show them in another way like this. Okay, this is the surface body 2, right? This is the body 2. Let me show it differently. Okay, this here we have a pin. Okay, let us say this is body 1. This thing is body 1, and here is a body, another body. Okay, body 2, structure 2. Okay, whatever you call it as, right? Now this is a roller support. Now what is the function of roller support? Now it allows the rotation at this point. It allows the body 1 to rotate at this point. It also allows to move left right or right to left. Okay, it means it allows left to right motion, and it allows rotation. But as you can see here, it does not allow up down motion. You see, this body 1 cannot go inside body 2, right? Because body 2, it is a solid body, it will resist, right? So if I show it like this, let me show it like this. Now body 1 can roll on the body 2 like this, right? it can move like this, okay? But you see it cannot go down like this. Why? Because there is body 2, okay? So the roller support allows left right motion and also the rotation at this point, okay? It allows rotation, okay? So the roller support, what it does, it allows rotation. Let me show it here. Roller support, roller support, what it does, it allows rotation, right? And it allows left right motion, right? Left right. Now left right in this case, now it can also be, the structure can also be like this. For example, it can also be like this, right? Now in this case it will allow up down rotation only, right? It cannot allow left right rotation, right? It can allow motion like this, right? So the thing is that it allows motion only in one direction, okay? Only in one direction, okay? Left right or up down. More appropriately I will write along one axis, along one axis only, okay? The axis is this, right? Now what does it prevent? It prevents what? Now it prevents what? It prevents motion in one direction, right? Translation, translatory motion, right? Because when you move things, that is a translatory motion, okay? And when you rotate a thing, that is rotational motion. Now more appropriately I will write translatory motion, right? Now let us talk about another support, that is pin support, okay? Now pin support is something like this. We only have a pin here, okay? And the body one is connected to it like this. This is body one, okay? And it is sitting on body 2, body 2, right? The pin support only allows rotation at this point, okay? It does not allow any another translatory motion, only allows rotation, okay? So when I talk about pin, it allows what? It allows rotation, right? Rotational motion, right? Rotational motion only. What does it prevent? And it prevents, what does it prevent? It prevents translational motion, right? Translational or translatory motion on, in what, how many directions? Two directions, right? Two directions. Because you see, something can translate left to right or it can translate top to bottom, okay? When we talk about two-dimensional objects, okay? If it was three-dimensional, then it would move back and forth, right? Now we are talking about two-dimensional objects, and in case of 2D objects, the possible degrees of freedom are left right motion, top to down motion, okay? Okay, now that's why you have written here different type of supports restrain motion in one direction and allows motion in another direction, okay? Because some allow direction rotation, some don't allow rotation, some allow motion in one direction, some don't allow, okay? So different types of supports, they restrain the motion or they allow the motion in different ways, okay? So let's move on. Now let us talk about connection. Now, what is a connection in statics? Now, connection is something which connects two bodies. Okay, now let me talk about, let us say we have a body here. Okay, this is body one. Okay, body one here. And let us say we have another body here. this is body 2. Okay, body 2. Okay, now if I want to connect these two bodies, I'm using something. Okay, for example, I am connecting these two bodies like this. Okay, so this thing, because it connects body 1 and body 2, it is a connection. Okay, this is a connection. Now a connection transmits force from one body to another. Now for example, if you apply a force here, okay, for example in this direction, you apply a force F on body 1. Okay, now this force will be transferred to this connection actually. Okay, like this, and this force will be transmitted to body 2 like this. Okay, and this body 2 will be pulled towards the connection, right, like this. Okay, so the force applied on body 1, okay, it is transmitted to body 2. Okay, this is a connection. Okay, it works similarly to the to a support. Okay, so let's move on. Now let's talk about this. What are support reaction and connection reactions? Okay, now a support reaction or connection reaction is equal and opposite reaction which is exerted back to the support or connection. Now let's say we have a body here, body. Okay, let's say we have another body here, and this body is a surface. Okay, frictionless surface, frictionless surface. Now let's say, no, let me move it a bit down. Okay, now let us say we have a roller support here. Okay, you can represent a roller support with the help of this. Okay, or also you can represent a roller with the help of this diagram. Okay, this is the same, they are both roller supports. Okay, let us say we have one support here and another support here. There is some force F. Okay, so this surface is going to, this F will be transmitted to the body, and the body will uh, send this force to these supports, right? Now here will be F by 2 and here will be F by 2. So these forces will be sent to these supports, and the supports will send forces to this surface, right? Because let us say there is F by 2 force on this surface from the support, and here is F by 2 force from this support on this surface. Now there will be a reaction on supports because surface is going to exert an equal and opposite reaction to the supports. Okay, because that's Newton's third law. Okay, so if this is the surface, so this is going to exert force like this, F divided by 2. Okay, and here will be F divided by 2. Okay, so these are known as support reactions. Okay, we denote them with R. Okay, or sometimes with Ry. Ry means if this is the vertical axis, y axis, so Ry means reaction in the y direction, or reaction in the vertical direction. Okay, so this is our support reactions. Now I have already made video lecture on how to find these support reactions. You can also watch them. Okay, so let's move on. Now the topic is how to calculate the number of support or connection reactions. Okay, now when a motion is restrained, there arises a reaction. Let me show you it here. Let us say this is a support. Okay, from this body, this is a body, for example body 1. Okay, and this support is resting on body 2. Okay, body 2. Now the body 1 cannot move up or down, right? It cannot move, right? This support prevents the up or down motion, right? And how it is possible? Because if you see, if your body one tries to move downwards, the body two will exert a reaction upwards, okay, so that the body one cannot move downwards, okay. The upward and downward motion is restrained. Why? Because there is a reaction against it, okay. The body one tries to move downwards, but there is a reaction from body two, right? It will be opposite to this. There will be a reaction like this, so there will be no motion. That's why when a motion is restrained, when you don't allow motion, there arises a reaction, right? This reaction is because the motion is restrained. If translatory motion is restrained, a force reaction occurs, and when a rotational motion is restrained, a movement is the reaction that occurs. Now here, let us assume this body 2, it does not exist here, okay. Now if you try to move the body 1, it will move like what? Translatory motion, right? It is not going to rotate like this. It is not going to rotate like this or this. It will move just from here. It will go down like this. Let me show you. It will move like this, right? So what type of motion is this? It is translatory motion, okay. So when there, but there is body 2, right? There is body 2. There is body 2. It will not let it move downwards. It will not let any translatory motion because of this reaction force, right? This reaction force, okay. So when a translatory motion is restrained, a force reaction occurs, okay. This is a force, right? This is a force reaction. Now you see, let me show you now. When a rotation motion is restrained, a movement is the reaction that occurs. Let me show you here. Let us say you have a support here, pin support, okay. Let me change the color first. Now now this is the pin, okay. Now when you apply a force on here, F, this body will move like this, right? It will move like this, right? So there will be a rotation at this point. Now if we exert more force here, there will be rotational motion like this, right? Then when you apply a force here, it will move to this position, right? Then when you apply more force here, it will move to this position. Whatever it is going, the motion occurs here, right? The rotation occurs at this point, right? So now let me restrain this, okay. Now let me close this pin, okay. Let me show it here. Now, initially it was a pin, it was allowing the motion, right? When it allows the motion, remember, when the motion is allowed, there is no reaction. When the motion is restrained, there is a reaction. Now let us say the here it was pin, there is no pin, okay. It's fixed now everywhere, and you apply a force here, right? Now again, this body have again tendency to rotate here at this point, okay. But it will not rotate because there is no pin at this point, right? But at here, F force was rotated. F have the tendency to rotate this body at this point, and because there is a pin at this point, a hinge at this point, it will rotate. Again here, the F force, it have a tendency to rotate this body at this point, right? But there is no pin at this point. What is going to happen? Now let me first tell you how does motion rotation occur, okay. How does rotation occur? The root, is rotation because of force? Is it because of force? No, rotation is because of movement, okay. Rotation is because of movement, okay. Now let us assume this force, you apply this force here, okay. You apply the force at the joint. Tell me, will the body rotate? No, it is not going to rotate. Now, when you apply the force here, the body will move slower. Okay. Now, when you place the force at the farthest point away from the joint, okay, the pin, the body will have more tendency to rotate. Okay. So the rotation is not because of force. Okay, the rotation is because of the movement. Okay, the rotation is because of the movement. Okay, now you will understand this statement yourself. Now now go to your room, okay, and apply a force on the door. Okay, door, let us say you have hinges here. Now try to apply force here. Okay, at this point you will see the door will not rotate. Now when you apply force here, the door will open slowly. Now when you apply the force here, the door will open fast. Okay, why? Because the door does not open because of the force, it opens because of the movement. Movement is force multiplied by distance. Okay, when you apply the force at the joints, okay, at the hinge, let us say this is door and this is the hinge, you apply the force here. Okay, now what is the value of movement here? Movement is force multiplied by distance. Force multiplied by distance. Now you want to rotate here, right? Because the door has to rotate, it has to rotate at the hinge. The distance between hinge and the force is how much? The distance between the hinge and the force is 0 because they are at the same point, so movement is 0. Now when you apply the force here, let's say it is 4 meters between the hinge and the force. Okay, now the movement is force multiplied by normal distance between force and the hinge. Okay, it is 4 meters. 4 meters. Okay, now movement is not 0 here, right? Movement is not 0 here. So because the movement is non-zero, that is there exists some movement. When you apply a force at this point, the door will open. It means the rotation is not because of force, it is because of the movement. Okay, now let us say there is a pin and you apply a force F here. Okay, of course the body will rotate like this. Okay, why it will move like this? Because there is a pin at this point. Okay, the movement, this is the direction of movement. Okay, this is force and the movement is like this. Now if you want to stop this rotation, okay, if you want to stop this rotation, what you will do, you are going to exert opposite movement, right? Opposite movement. So the net movement is 0, right? Let me show it here. Let us say this is the body and this is the hinge. Now you apply a force here. Okay, now because of this force there will be a movement like this, right? Because movement is in the direction of force, right? This movement will try to rotate it like this, right? The rotation at this point is only because of movement, right? Rotation is because of movement, as you can see here. Now if you want to stop this rotation, what you are going to do? Because rotation is because of movement, you are going to exert an opposite moment. Okay, opposite moment against this moment. Okay, this opposite moment is the reaction, right here. This is the reaction. It means you are going to exert a moment like this against this moment. Then what is going to happen? There will be no rotation at this. In short, what I mean to say, if you want to stop the rotation, the reaction will be a moment. Okay, the reaction will be a moment. And if you want to stop a translatory motion, okay, like this body will not move up or down. Why? Because when you apply a force here, there is a reaction like this, right? So the translatory in case of when you stop the translatory motion, the reaction is a force, and in when you try to stop a rotation, the reaction is a moment. Okay, so that's what was written here. when a rotation motion is restrained, a movement is the reaction that occurs. Okay, now number of restrained motions is equal to number of reactions. Okay, let me tell you here. Let us say this is allowed. I mean, the body is allowed to move like this and this. Okay, now the body is not allowed to move up or down, right? Because you see there is a surface. When you try to move the body, this body downwards or upwards, when you try to move the body one downwards, there will be a reaction from this surface against the motion of body one, so there will be no rotation in the vertical direction. Okay, so the number of reactions is like this, right? When you apply a force here, there will be a reaction against it. Okay, the reaction will be from this surface. Okay, so you restrain one motion, up down motion, right? This was up down motion, you restrain it. Okay, you stopped it, so there is one reaction. Okay, now let us say there is no hinge, there is no pin at this point, so there is what, rotational motion is stopped. So rotational motion will be stopped only when you apply, when this support will exert a moment like this, right? This support will exert a moment on this body, so you stop the rotation, you stop rotation, moment occurs, right? Moment, right? So this is one, right? Moment, it is one term. So you see, more you stop the motions, you stop up down, there is one reaction. Now you stop the motion, okay, there is another reaction. Okay, one reaction again. Okay, so 1 plus 1 total reactions is 2 reactions, right? 2 reactions. Why? Because you stop 2 motions, isn't it? You stop what? You stop up and down, and you stop the rotation. You stop 2 motions, and what do you get? You get 2 reactions, right? So the more motions you stop, the more reactions you will get. Okay, you will get exactly that amount of reactions. Okay, that's what was written here. Number of restrained motions is equal to number of reactions. Okay, don't worry, when we solve more and more problems on this, you will understand it more and more. Okay, just keep watching the lectures in sequence. Okay, now this is the support and connection chart. As you can see here, I have mentioned more type of supports and the connections. Okay, initially I just told you about the roller support. Okay, the pin. Now right now you see this is the body. Let me show you this thing here. Okay, you see this is body, and there is a roller support. Okay, this green, it is a roller support. this is a this is a roller support. Okay, roller support means what? You can move it towards right, you can move it towards left. Okay, so left right motion is allowed. Okay, you can also rotate it here. Okay, you can also rotate this here. The roller will not stop you from rotating, and there is only one rotation stopper. Which is it? It is up down, right? Can you move this body downwards? You cannot, because there is a surface, you cannot move it down, right? So one motion is restrained. How many motions are restrained? How many motions are prevented? One, right? Because you can move it left and right, you can also rotate it, so only you cannot rotate it up or down, so one motion is restrained, so the number of reactions is 1. Okay, and remember, the reaction is always perpendicular to the surface. Okay, you see the force is here, so the support is going to exert force here at this point. Okay, and there will be a reaction from this surface to this support, and it will be perpendicular at 90 degrees or normal to the surface. Okay, that is why it is known as, this reaction, it is known as what? It is known as normal reaction. Okay, which we have already talked about, normal reaction. Now let's talk about rocker. Okay, What is a rocker? Now you see, this is a body, this is a body, and this is a rocker. Okay, rocker is same as pin, roller support. Okay, now with the help of rocker, you can, the rocker is like this. You can rotate a body on it. Okay, you can rotate a body on it. Okay, you can also move it left or right, but you cannot move it up or down. Okay, so only reaction is one, and the reaction is always at 90 degrees to the surface. Okay, this is the normal reaction. Okay, now frictionless surface. Now this is the frictionless surface, right? That is, mu is 0 here. The frictionless surface, what is it is going to do there? When you apply this body, there will be some weight of this body, or let us say there is some force F on it. Okay, the force will be on this surface, and the surface will exert a reaction against, right? So there will be a reaction, and it will be again normal to the surface. Okay, there is only one motion that is prevented, that is up or down. It is not allowed to move up and down. Now because it is frictionless, you can move it here or you can move it here, right? Because there is no friction which will stop it. Okay, you can also rotate it like this or like this. So only one motion is restrained, so only one reaction. Okay, and that is also perpendicular to the surface. Okay, then we have hinge or pin. Now now hinge or pin, it is only going to allow the rotation. Okay, it will only allow you to rotate like this. Initially it was like this. If you apply a force here, you can rotate it like this, but the only thing which you cannot do, you cannot move it left or right. You can also not move it up or down. So two motions are restrained, right? So there will be a motion, reaction against this. When you restrain the up and down motion, there will be a reaction in vertical reaction, and when you prevent the left right motion, there will be a reaction in that direction. Okay, so two motions prevented, two reactions, ry and rx. Okay, so as you can see here, we have only two reactions. Now fixed support. Now fixed support is something which does not allow anything. Okay, it does not allow rotation, it does not allow move left or right, it does not move allow up or down, nothing. Okay, so of course when you don't allow left right, when you don't allow left right, there will be a reaction. Okay, in this direction. When you don't allow up down, there will be a reaction in the up down direction, right? And when you don't allow the rotation, right, because rotation is because of moment, so the support will exert a moment to the body, right? This is the body, this is the fixed support. So there is a moment, so there is a reaction. This rx reaction prevents left right motion, this ry reaction prevents up down motion, and this moment prevents the rotation. Okay, so 1, 2 and 3 reactions. Okay, 3 reactions. Similarly, now this is not a support, this is a connection. Okay, because it is connecting these two bodies. This is body 1, body 1, and this is body 2. Okay, b2. Now this is connecting them. Now when you apply a force here, for example, you apply a force here, wherever you apply a force in any direction, the reaction is always parallel to cable. Okay, remember this is a cable, this green is a cable. Okay, and the reaction is always parallel to it. It doesn't matter how you apply the force. If you apply the force like this, reaction, okay, or you apply like this, F, or you apply like this, whatever you apply, the reaction force will be always along the axis of cable. Okay, along the axis of cable, this will be the reaction. And how many reactions are there? Only one. Okay, only one reaction. Similarly, short link is like the cable and short link, they are the same thing. Okay, wherever you apply the force here, the reaction will be always along the short link. Okay, the length of the link. Okay, there will be reaction, it is 1. Now pin in the slot. Now you see, this is a body and there is a slot. This is a cut out hole in it and you put a body inside it. Okay, now you try to move it, it will always, you can move it anywhere but you cannot move it inside the inner surface. Okay, you cannot move it like this, it is not possible. Why? Because this is solid here. Now what thing is preventing it to move here or move here? What thing is preventing it? It is this inner surface, right? This inner surface is preventing it. You know, you can move it like this or you can move it like this, right? You can move it like here or you can move it here, right? But you cannot move it like this. So there is this surface or this surface which is preventing it. Okay, so there will be a reaction perpendicular to the inner surface. Okay, so if you apply a force here, for example, there will be a reaction at this which will be perpendicular, normal or 90 degrees to the inner surface. Okay, so there is only one reaction because you only stop this motion, right? You only stop this motion, so you stop one rotate motion. Of course you can rotate it, if it is like this you can rotate it like that, right? Anywhere. And you can also move it like this, but you cannot move it like this, right? You cannot move it here or here. So one motion is restrained, so only one reaction, as you can see here. Okay, so this way we found the support reactions. Okay, if you have any doubt please comment, and in the coming classes we will solve many problems on how to find the support reactions. So that's it, see you in the next class. Thank you.